Find I cross k and k cross I using the original definition of A cross B. Right, so that means we're just going to use the determinant. I'm not going to use the formula book method. Part B, check that the right-hand rule correctly gives the direction of I cross K and K cross I. Remember that the cross product will always be perpendicular, but it could be one way or another, so we'll look at that. Part C, check that A cross B equals the magnitude of A times the magnitude of B times sine theta, where theta is the angle between A and B, times some unit vector u, where u is the unit vector in the direction of A cross B, right, which we're going to have worked out from part A anyway. Check that that is true for I cross K and K cross I. Okay, so part A, I cross K and K cross I. I cross K equals, well, I is a unit vector in the x direction, so it's 1, 0, 0. K is a unit vector in the z direction, so that is 0, 0, 1. Remember I, j, k. So that equals I, j, k, 1, 0, 0, 0, 0, 1. 1, 0, 0, 0, 0, 1. And it is the determinant of all of that. Okay, so that equals I times the determinant of, if we just get rid of I's column, that leaves 0, 0, 0, 1 minus j times the determinant of, if we remove j's column, we have 1, 0, 0, 1. Remember, it's always minus j plus k. K times the determinant of 1, 0, 0, 0. Okay, so this will have a lot of zeros in, clearly. So it's I times, well, 0 times 1 minus 0 times 0 minus j times 1 times 1 minus 0 times 0 plus k times 1 times 0 minus 0 times 0. Just like that. So that equals no i's minus 1j plus no k. So it equals base 0i minus j plus 0k. So that just equals minus j. I cross k is minus j. K cross I. Now we have been asked to use the original definition, so I'm going to do it the long way around again. So K cross I, well, that is going to be, we're just going to reverse these. So 0, 0, 1 cross 1, 0, 0. Cross 1, 0, 0. So that is I, j, k. 0, 0, 1, 1, 0, 0. And the determinant of all of that. So that gives us I times the determinant of 0, 1, 0, 0 minus j, always minus j, 0, 1, 1, 0 plus k times the determinant of 0, 0, 1, 0. Right, so that equals I times 0 minus 1 times 0 minus j times 0 minus 1 times 1 plus k 0 times 0 minus 0 times 1. Doesn't quite fit, it's just going to be 0 anyway, so that equals no i's. You've got minus 1 times another minus 1, so it's plus j plus 0k, which just equals j. Okay, so that was part A. For part B, we need to check that the right-hand rule correctly gives the direction of I cross K and K cross I. So I'm going to show you how to draw a true 3D axis system. And it's very easy actually, but you do need to make sure you remember which way the z-axis goes. So this is the y-axis, this is the x-axis, so x and y, and the z-axis, if it wants to be truly 3D, it needs to point out of the board or into the camera, just like that. So the z-axis in the positive direction is the pen pointing up like that, right? So I now need to find I cross K and K cross I. Okay, so if you think about I, well, I is a unit vector in the direction of the x-axis, so that can be I. K is a unit vector in the direction of the z-axis in positive direction, so K is a vector of the same length pointing along with the pen. So if I point my fingers along the direction of I and then I swing them towards K, which remember comes out of the page, the thumb tells you the direction of the I cross K, so you can see that's pointing backwards along the y-axis. Okay, so that shows you that the direction is in the minus j direction, so you can see how it could be minus j. If I want to do K cross I, well, I need to start at K and then cross towards I. So if I start with my fingers facing along K, so along there, and then I swing them back towards I like that, then you can see my thumb is pointing in the positive direction of J like that. So I start here and I swing my fingers that way. And that shows you that the direction of K cross I should be in the positive Y direction, so along the direction of plus K. Along the direction of plus J. Okay, so it's quite hard to demonstrate, quite hard to get these angles on this board, but try it for yourself. Just point the true 3D axes, it's your x and y that you've been used to from the whole time you've done maths, and z just points out. And if you want to do one of these unit vectors cross another, then you start with your fingers facing the first one, and you need to swing them towards the second one, and wherever the thumb is pointing, that will give you the direction of the cross product. Part C, check that A cross B equals the modulus of A times the modulus of B times sine theta u, where u is a unit vector in the direction of A cross B. So check that that is true for I cross K and K cross I. Okay, so for part C, so the unit vector that we're interested in the direction of I cross K was minus j. That's a unit vector and it's in the direction. So the unit vector u equals minus j for I cross K. Okay, so we need to check that A cross B equals the modulus of A times the modulus of B times sine theta sine u. So A cross B, we already know that I cross K equals minus j. So we need to check if minus j equals the modulus of I times the modulus of K times sine of the angle between them. Well, the angle between I and K is 90 degrees. Sine 90 times the unit vector in the direction of I cross K, which we already said was this, minus j. Okay, well, sine 90 equals 1. The modulus of I is clearly 1, the length of the unit vector I. As with K, that is 1, so 1 times 1 times 1 times minus j does equal minus j, which is our value for I cross K, so that's fine. If we do the same for K cross I, we know that K cross I, from our calculations, well, that equaled positive j. Does positive j equal the modulus of K times the modulus of I times sine of the angle between them, which is still 90, times the unit vector in the direction of k cross I, which was just positive j. So is that true? Well, you have 1 times 1 times 1 times j. Does that equal j? Yes, it does. Okay, so everything holds. I think the hardest bit to get your head around for this particular section is this direction of I cross k. I don't think you're unlikely if you have to do too much with it, and the good news is you can always get the direction from using the mathematical processes anyway.